this video, we're going to look at equations of circles, specifically circles centered at 0, 0, at the origin. So we're not going to look at circles centered at other points off the origin, as these have slightly more complicated equations, and we'll cover these in future videos. In this video, we're just going to introduce the idea of an equation for a circle by starting with circles centered at 0, 0, as they're a little easier to handle. So far we've seen in these videos a lot about equations for straight lines. So that's equations of the form y equals mx plus c, which we know when we plot them on a graph give us a straight line. Well, now we're going to look at equations which give us a circle when we plot them. So let's start with an example. So here is a circle centered at the origin. You can see it has radius just about a little over 2. We don't know exactly what it is, but it's not so important. It's a circle with some radius r, and it's centered at the origin. Now let's take a line here from the center of the circle to a point on the circle, and we've labeled the point x1, y1. Well, we know the length of this line must be r, where r is the radius of the circle. Now, what else can we say about the line? Well, if we make this triangle here a right-angled triangle, then we know that this length here is x1. So the length of this side of this triangle is x1, as x1 is the coordinate of the point on the circle. And this length is y1. We can see this just by looking at the diagram. So if these lengths are x1 and y1, and the hypotenuse of this triangle is r, then we can use Pythagoras' theorem to tell us that x1 squared plus y1 squared equals r squared. So what have we stated here? We've stated that the length of the line, so the radius of the circle, when we square it, is equal to the sum of the squares of the two coordinates of the point that the line is going to. So we have a line going from the center of the circle to a point on the circle. We take the coordinates of that point, square them and add them up, and it's equal to the radius of the circle. And in fact, this will be true no matter what point we take. Say we take a point over here, we call x2, y2. Once again, the length of this line is r. Once again, we form this triangle. We know that this length is now x2, and this length is now y2. So x2 squared plus y2 squared equals r squared. So this is the same r as we had in the first equation, but we clearly have a different x and y here. So x2 is not equal to x1, and y2 is not equal to y1. We can see that from the diagram. But nonetheless, when we square them and add them up, we get r squared. And you could do this, you could keep drawing lines and triangles like this. You'd see that no matter what point you took on the circle, this was true. So for any point x, y on the circle, x squared plus y squared equals r squared. So hence, if you take this equation, x squared plus y squared equals r squared, and you let x and y be variables, then any numbers that satisfy it as pairs, they give us a point on the circle. And if they don't satisfy it, they must be off the circle of radius r, centered at 0, 0. So we can take this as a definition of a circle equation. So the equation of a circle with radius r and center 0, 0 is x squared plus y squared equals r squared. So x and y are variables, but r is a constant. So we have to decide, if you like, what radius we want. So say we want to write down the equation of a circle with radius 3, then that would be x squared plus y squared equals r squared, which in that case would be 3 squared. But we'll look at that example next. So first of all, we'll just note that this is not of the form y equals f of x. So with straight line equations, we have y equals mx plus c. So the y is on the left-hand side of the equal sign by itself. But here we have the x and the y together on the same side. So it's maybe not quite what we're used to. Right, now let's look at a few examples. So example 1, write down the equation of the circle with radius 3 centered at 0, 0 and sketch it. Well, I just described this example when talking about the definition above. So we know from the definition that the equation of the circle is x squared plus y squared equals 3 squared, since we want radius 3, which is 9. So we have x squared plus y squared equals 9. Now to sketch that, say if you were doing this on graph paper with a pencil, you would want a pair of compasses. You would go to, if you go to 3 on the x-axis, since you want it to be centered at 0 and have radius 3, and then put your compasses on your paper as such, then you just draw the circle round and you'll get something that looks like this. So that's how you would sketch that. Let's try a second example. So example 2, write down the equation of the circle in the diagram. So we can see, since we've drawn it onto squared paper, onto a graph paper, that it has radius 2. So we know this is a circle centered at the origin. We can see that too, and it has radius 2. So that means its equation must be y squared plus x squared, or x squared plus y squared. You can have the two either way around since we're just adding them up. So y squared plus x squared equals 2 squared, which is 4. So that's very straightforward. Let's look at one final example. Sketch the circle with equation 2x squared plus 2y squared equals 32. Now this looks like a bit of a trick because that equation doesn't seem to be in the form given at the top, the form of a circle equation, because there are numbers in front of the x and y. But as is often the case, sometimes an equation can look like it's not in the correct form, but you can rewrite the equation so that it is in the correct form. So we take this and we note that there's a 2 in front of the x, a 2 in front of the y, and 32 can be divided by 2. So maybe we can factor a 2 out and cancel. So what do? We factor a 2 out of the left-hand side. So we take a 2 out of the x squared, the 2x squared, and the 2y squared, and we end up with 2 times x squared plus y squared. So this is factorization. And we note that on the right-hand side, 32 is 2 times 16. So we've got 2 multiplying on both sides, so we can cancel them off. And we just end up with x squared plus y squared equals 16. And that is, of course, the same as x squared plus y squared equals 4 squared, because 16 is 4 squared. So this is now in the form at the top. We have x squared plus y squared equals r squared, where r is 4. So this is, in fact, the equation for a circle centered at 0, 0 with a radius 4. Which would look like that.